Okay, Assalamualaikum and good afternoon to all my students. So for this video, I will show you the solution how to solve the problem that I have given in the Google Classroom. Okay, so I think most of you have already done this. So this solution that I will show you is just a comparison with your results, with your solution results. So if your answers differs with my answers, so we can discuss it in Google Classroom, or also you can ask or discuss it in our WhatsApp group. Okay, so this is the question. A hydrostatic transmission operating at 70 bar pressure has the following characteristic. So there are two types of properties here. This one are the properties for the pump, and these are the properties for the motor. And the question wants you to find the displacement of the motor. Okay, so displacement, this one is in the unit of meter cube per revolution. So how many cube in one revolutions? Okay, for A, displacement of the motor, we start with the equation of volume flow rate of the motor in theoretical of the pump. T here means for the theoretical value, P means for the pump. So the equation for the pump and the motor equation is similar. Okay, the difference is the value that that are given here. Okay. Okay, sorry. Okay, so to calculate the QT for the pump equal to displacement of the pump times with the speed. Speed here must be in the unit of revolution per second, because of the unit for the pump displacement here is meter cube per revolutions. Okay, so that's when we multiply Vd with the speed, so we can cancel off the revolution unit here. So finally we will get the unit of meter cube per second. Okay, so 82 times 10 to the power of minus 2 times the power of 3 here because of meter cube, so we have to multiply with 3. And then where I get this value, okay, this is given here for the pump. Okay, where I get the value of speeds here, and this one is given in the question here, 500 revolution per minute RPM, but we have to convert the RPM into the unit of revolution per second, so you have to divide it by 60 because there are 60 seconds in 1 minute. Okay, so I will get the value of 82 times we will get 0.000683 meter cube per second. Okay, and then I use the equation of QA actual, volume flow rate actual for the pump, equal to volume flow rate of the theoretical times with the efficiency, volumetric efficiency. There is given here NV here. Okay, 82%. So from this value, you substitute into here 0.000683, and then you will get the actual flow rate for the pump is 0.00056. 0.006 meter cube per second. Okay. Okay. And then this is the value for the pump. The question wants you to find the VD of the motor. Okay, by using the same equation here, QT of the mechanical of the motor here, M is for the motor, equal to QA times efficiency, volumetric efficiency of the motor. So NVM here is given in the question, 0.92 equal to 92% here. And then QA for the pump, you get this value, you substitute here, 0.00056006. Then you will get 0.000515 meter cube per second for the motor, flow rate of the motor. Okay, by using the efficiency, this equation, that flow rate equal to volumetric displacement times with the speed. So now we are going to use this equation for the motor. So I rearrange that, then I will get the value of VD. VD is here, is the displacement of the motor. That's the question in A. Okay, so 0.000515, the value here comes from the solution that I have already calculated, and then you divide by, okay, the speed of the motor also is given in the question here, 400 rpm, but you must convert it into the revolution per second. So finally I will get the value of 0.00773 meter cube per revolution. Okay. Okay, if you want to convert to centimeter cube per revolution, so you have to 0.000773 meter cube, you have divide by 10 to the power of centi is -2, where meter cube you have to multiply with 3, so you will get 773 centimeter cube. Okay, 1 2 3 4 5 6. Oh, it's not, forget one. Okay, so 7.73. Sorry, 77.3. Okay, so that's the answer for A. And for B, the question asks you to find the motor output torque. So this one is the actual torque of the motor. Okay, So from our equation here, the efficiency of the motor equal to actual torque over theoretical torque. So the equation for the theoretical torque comes from the VD, volumetric displacement of the motor, times with the pressure. Pressure is given right 70 bar. Okay, VD here comes from the here. Okay, 77.3 meter cube, centimeter cube per revolutions. Okay, by using this equation, so they rearrange that TA actual torque equal to efficiency of the motor times with the theoretical torque. So I use this equation, I substitute into that. I just use this equation and merge with this equation. So you just substitute with the value that you have. Okay, the efficiency of the motor itself, mechanic 90%, so I put it the value of 0.9. Okay, so VD here comes from the value that you have calculated in A here. So I put it 77.3 centimeter cube times to the power of -6. Okay, times 70. Pressure is 70 bar. So in Pascal, you have to convert into that 70 times 10 to the power of 3, because 1 bar equal to, oh, it said that bar, right? Okay, 1 bar equal to 10 to the power of 5 PA. So this is wrong. Okay, this should be the 5. Okay, so divide by 6.28. Why is this 6.28? This is the constant value that is already there in the question itself. So you can refer back to your question of the torque here, because there is 6.28. There is the constants for the unit SI. If you do this in the imperial unit, so there will be different constant value here. Okay, so let's calculate using your calculator. So finally, my value is 77.546 Newton meter. This is the value of the torque, actual torque. Okay, so that's it. This is answer for B. This is the answer for A. So if you have problem with the calculations, first let's discuss it, and before that, before we try to discuss it, try to find your errors or your mistakes in the calculations first. If you do not understand a certain thing in the calculation, then we try to discuss in our Google Classroom or our WhatsApp groups. Okay, thank you. That's all for this video. This video only want to show you the solution of the question here. So that's all. Assalamualaikum. Good afternoon and bye bye.